This is the second tutorial for Chem 1011. In this tutorial we're going to be looking at interconverting between energy, which is usually indicated with a capital E, and frequency, which as we saw in the first tutorial is indicated using the Greek letter nu, which looks like a V but is not actually a V. The wave nature of light actually does not correctly explain the distribution of wavelengths emitted by a glowing object. This was called blackbody radiation. Max Planck realized that he could explain this phenomenon by assuming that energy comes in packets called quanta. Einstein then went on to use Planck's idea to explain the photoelectric effect. The photoelectric effect was an observation that when you shone light on a metal surface, you could get it to eject electrons. But it was only above a certain frequency that you would see this phenomenon. Below a certain cutoff point, you wouldn't see the ejection of any electrons whatsoever. And Einstein proved that light had these properties of quanta, not just waves. Okay, so you had to have a certain amount of energy. You had to get over a certain threshold before you could eject an electron. And so he concluded that photons have an energy proportional to frequency. And the formula that you can use is E equals h nu, where h is Planck's constant and has the value 6.63 times 10 to the negative 34 joules per second. So, if you get a question like this, determine the energy of a mole of photons with a frequency of 1.66 times 10 to the 17 hertz, or seconds to the minus 1. You can solve it using this equation. Planck's constant, 6.63 times 10 to the power of minus 34 multiplied by 1.66 times 10 to the power of 17. Plug that into your calculator and you should get an answer which looks, hopefully, something like this. And energy, when you're using SI units, is given in joules. Now the question actually asks to determine the energy of a mole of photons. Here we've given the energy for one photon. And so to answer the question properly, we need to multiply this value by Avogadro's number. Okay, this is the number of anything in a mole. So we multiply this by Avogadro's number, and that's 6.02 times 10 to the 23. That should give you a value which hopefully looks something like this. Joules per mole.